Hey guys, welcome to our first learning target of our factoring practice. Our first learning target is I can factor quadratic trinomials with a equals 1, which look like x squared plus bx plus c. Now, x squared plus bx plus c is called a trinomial because it has 3 terms. We get trinomials from multiplying, usually, 2 binomials. So right here, it says multiply the 2 binomials. These are called binomials because they each have 2 terms. A monomial would be one with 1 term, okay? So we're going to multiply these 2 binomials and see how we can end up with a trinomial. And then we're going to see how we can undo that, and that's called factoring. All right, so let's start off. Let's distribute this x from the x plus 3 to the x in the second binomial, that would be x squared, and then to the 5, that would be 5x. Then distribute the 3 to the x, that's 3x, and the 3 to the 5, that's 15. Now, we can combine the like terms of 5x plus 3x, which results in the trinomial x squared plus 8x plus 15. Now, do you guys remember that when a quadratic is in this form, it is called standard form? And remember, standard form is ax squared plus bx plus c. So, if you didn't notice, in our learning target, it says a equals 1. Well, yes, a equals 1 in this case that we just multiplied because it just says x squared. When it just says x squared, remember there's a 1 in front of it. We don't really write that because it's implied that there is an x squared there if we wrote it. Then our b value is 8 and our c value is 15. Our question is, where did 8 come from and where did 15 come from? So if we look back at our factors, we see that we had x plus 3 times x plus 5. And when we multiplied those, our 2 middle terms were 5x and 3x. Do you see that those are the numbers that were in our binomials to begin with? So the 2 numbers in our binomials were added to give us this middle term, our b value. And then the 15, how did we get that? We took 3 times 5. So they were multiplied to give us our c value of 15. So when we are factoring trinomials with just a equal to 1, we really only have to consider what these 2 numbers in our binomials would be. So in this next little section, it says, when factoring quadratic trinomials, we are undoing what we did above. When a equals 1, we know the first term in each binomial is x. Reason for that is the only thing that's going to give us x squared is if we just take x times x, okay? So we know that right off the bat. If our first term is x squared, we know that in the binomials, we just have x to lead off both of them. So after we know that, we just need to figure out what 2 numbers go in each factor. So as I just talked about, my b value in my standard form came about by adding the 2 numbers that I had in each factor, and my c value came about by multiplying those 2 numbers. So when we're given a trinomial, we need to ask ourselves, what 2 numbers multiply to equal c and add to equal b? So here's an example. The trinomial x squared plus 7x plus 12. C is 12. So list the factor pairs of c, which is 12, and choose the pair that adds to b, which is 7. Now, some of you might be able to do this right away, but I'm going to go super slow. I could take 1 times 12. I could take 2 times 6. And I could take 3 times 4. All of those are pairs that will multiply to 12. But which one of those adds to 7? 1 plus 12 is 13. Definitely not going to be that. 2 plus 6 is 8. Nope. And finally, 3 plus 4, that is 7. That's our winner. So the factored form of x squared plus 7x plus 12 would be x plus 3 times x plus 4. Now, just so we don't have this question in the future, it does not matter which order you write your factors. So if you happen to write x plus 4 first, that is totally fine. Those are equivalent because multiplication is commutative. All right, let's try some examples. Now, some of these will be different because we might have some negative signs going on, but we'll figure those out when we get there. Letter A, let's check this out. C is 7, so we need to list the factors of 7 oh, 7's a prime number. We only have 1 and 7. So hopefully those add to equal our b value of 8. And sure enough, 1 plus 7 is 8. So we know we're going to have x plus 1 times x plus 7. All right, that is our answer. Moving on to B. I have a C value of positive 10, but look at my B value is negative. So how do I multiply to get a positive number, but add to get a negative? That means that both my values have to be negative, because either I have to multiply two positives to get a positive or two negatives to get a negative. But if I want a negative B, I'm going to have to have two negative numbers. So let's just list our factors of 10, knowing that they're both going to be negative. Or I could even start off going x minus, boom, x minus. I could take 1 times 10. Does that add to 11? Oh, it does, but I'll do 2 times 5 just to show you. So if I had a negative 1 plus a negative 10, putting those together does get me a negative 11. So x minus 1 times x minus 10. Then 2 and 5, that would give me a negative 7. That's not going to be what we want. All right, let's look at C. This one is, again, different. My constant, my C at the end is negative 90. That means that one of my numbers is positive and one of my numbers is negative. So when I think about that, instead of thinking what adds to my B value, I think about what pair, whoops, sorry about that, guys. There we go, sorry. What pair of factors has a difference of my B value of 1? So I'm going to list the factors of 90. There are quite a few. 1 and 90, 2 and 45, 3 and 30, 5 and 18. What about 9 and 10? Okay, let's start with those. If I don't find one that works well, I'll have to keep going. So I want to know, one of these is going to be negative, the other one's positive. Think about which pair has a difference of 1. 1 and 90 has a difference of 89. Nope. 2 and 45 has a difference of 43. 30 and 3 has the difference of 27. Nope. 5 and 18 have a difference of 13. 9 and 10 have a difference of 1. Now, do I want to take 10 minus 9, or do I want to take 9 minus 10? That's my question. Well, that's when I look at my B value, and it's a positive 1. So I'm going to want a positive 10 and a negative 9. So I'm going to go x plus 10 times x minus 9. Because 10 times a negative 9 gives me a negative 90, and 10 minus 9 gives me 1. All right, the next one is very similar to that one because our C value is negative, but our B value is positive. So when C value is negative, instead of think adds to B, you can think has a difference of B. So let's list our factors of 12. 1 times 12, 2 times 6, 3 times 4. Which pair of those has a difference of 4? 1 and 12 have a difference of 11. 2 and 6 have a difference of 4. So we want to choose 2 and 6. Now I want a positive 4. So that means I would want an x plus 6 times x minus 2. Because 6 times negative 2 gives me a negative 12, but 6 minus 2 gives me a positive 4. Okay. Now let's choose, I'm going to do one more and we'll do the rest in class tomorrow for this section. I have x squared minus 10x plus 9. This is one of those cases like B right above it where my C value is positive but my B value is negative, which means both of my factors of C have to be negative. So I could have a negative 1 times a negative 9 or a negative 3 times a negative 3. Now which pair of those adds to negative 10? That'd be negative 1 and negative 9. So I'm going to go x minus 1 times x minus 9. Okay, we are going to finish this learning target in class tomorrow.